And one thing to understand about this uh, features of these complex environments is that it's the difference between interaction dominant causality and component dominant causality. So this quote that I pulled here is it says that in an interaction dominant system, inherent variability, fluctuations or noise, or any individual component propagate through the system as a whole. So something happens to a component, and then it moves to other parts of the system. So if we have a component, it alters it something happens to it, and then what happens, it affects how it deals with or how its neighboring components are working. So uh, the inherent variability in any individual component C changes, and then it propagates through to other components, say D, E, and F. And because of the dense connections among the components of the system, the alterations of the dynamics of D, E, and F will lead to alterations of the dynamics of the original component that was affected. And so that initial random fluctuation of component of the original component will reverberate in the system. So it will so it changes, and its neighbors adapt, and then it has to, because it's connected to its neighbors, uh, it will adapt to the adaptation of its neighbors. And so, for example, the financial market is very much like this. But the same dynamic can be seen in very many different systems. Whereas in component dominant systems and component dominant causality, these parts of the system are not really that connected to each other. So we can actually look at, okay, so what does each component do? And so if we have a problem, for example, we can take all the facets of that problem or break it down into sub-problems. And then we can take all of those sub-problems and solve each one individually. And then we will see that the large problem has been solved. But in interaction dominant systems, this may or may not work, because the problem actually emerges from the uh, interactions between the components. So the problem is not within the components, but it's in those in the relations of those components, so to say. And this is why when we change one component, we can't necessarily predict what it will do, or if we change one sub problem, we can't necessarily say what will happen to all the other problems that are, because they're connected to this first problem. It may be a sort of almost like a leverage point, a term that's been used, that you change this one thing and then everything else starts changing for the better. But it could also very well be that everything else starts changing for the worse. And we have a lot of examples for this that we will talk about in the next section. But if you're interested, here are two quite interesting papers regarding this, and especially if you're thinking about generalizability issues and replication that we spoke in the first two sections of this course. So about this replication crisis, or the crisis of confidence. And yeah, so I warmly recommend this one on the right for that.